There's the goal.
All right. So, this is 350, right?
Yep.
Operating systems. First of all, there is already a homework assignment up. Another interesting thing that I'm starting this semester, another Christian worldview thing, is every one of my classes is going to have an associated Bible verse.
Cool.
And they're going to be revealed second day of class.
Why not the first day?
No, I actually have them. I actually have them for two of them. 470 will be revealed on the first day, but the Bible verse has to do with the difficulty of the course. So 470, I've picked a selection from Revelation. How many of you are taking 470? Oh, your life is over.
You're taking too many of your classes.
All right. So, in any case, there is already a homework assignment up for this class.
Where do we find homework assignments?
It's on Blackboard.
How do we use that? I've never used it before.
All right, hold on. Everybody relax. So we're going to log in here to Blackboard.
There's a link to the Blackboard site through your my.gw.
All right, everybody shut up. All right, so when you go into the portal, there's a Blackboard Learn link, whatever. So go into 350, and then over here on the left, you'll see assignments. The syllabus is up there too, but you'll see assignments. And on there, here's homework 1. You have to go to cuwcsslack.com. Make sure you've joined. Most of you should already have an account from last semester. But if you don't, you can create an account with your CUW. It'll be right in. And then make sure you join the 350 channel. And you got to post some stuff in there. I tell you what to post. That'll fulfill your first assignment. That has to be done by 10 a.m. on Wednesday to get credit for that, to make sure everybody's in that channel. I would recommend that you all get the smartphone app for that so you can get your push notifications, because sometimes I'll post stuff in there, or other people will, other classmates will post questions or whatever, and you can see those. But anything I post in Slack will be as if I had emailed it to the whole class. So you'll be responsible for that information. So it's a place. He's been engaged for like a year. All right. Make sense? Questions, comments? So that's Slack. We'll be using it. We'll be using it a moderate amount for part of this course from my perspective, but I encourage all of you to use it often. In fact, several people have done study groups and stuff. You can create private groups on there and do study groups, and that might be extremely helpful. This class somewhat, but I would say very helpful in 470 for those of you taking that. All right, so in any case, that's the homework assignment. Let's go through the little syllabus flippy-dealy thing, and then we'll just dive in. All right, so this is operating system, so we're going to learn about operating system crap in here. Now, one thing that's kind of a misnomer is we're not going to be learning about Windows or about Mac OS or Linux. We might talk about some of those things, but when we talk about operating systems, we're talking about the underlying data structures that not data structures, the underlying software that lives under the hood of our operating systems that do things like processor management, memory management, file systems, things like that. Okay, how our driver system works for, when you get a new piece of equipment, you have to install a driver. What the heck does that mean? Okay, so we're talking about what's actually happening under the hood in our operating systems, as opposed to, where do you find Notepad? Okay, that's not this class. That's CSC, I'm an idiot or something. Okay, so in any case, that's what the class is kind of about. Blah, 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 normal crap. Homework assignments, 45% of your grade. I will do pop quizzes as usual, 15% of your grade. Then a 20% midterm and final. I would plan on having a minimum of 1 assignment per week, probably between 2 and 6 assignments per week.
Sounds about right. Standard.
My real feeling is in the past, especially in the programming classes, I have not given enough homework. What's up?
You gave us one every single day.
That's true.
Should've
That's
given
not
it to
enough.
Might have some free time.
So I'm going to be giving extra assignments this semester, but not extra credit. Actually, some of the assignments are only going to be worth half of an assignment credit. That's why you have to do the extra ones to make up the other half. All right. So normal 90, 80, 70, dealy flippy, blah blah blah. Nothing weird there. So good. Somebody's already doing their homework. Questions about that? Any of the normal jazz? All right. There is, well, I would say there is sort of kind of a book for the class. I won't actually use it. I'll show you it here. Do I have it up here? No, there's not. If you happen to go online and find it someplace, let's just go to Amazon here real quick.
Operating system context. That one you're
Yeah, how many of you have ever seen the movie Hackers?
Oh my God!
Angelina-
How old am I?
Angelina Jolie was in it, like before she was Angelina Jolie.
That is a classic, people. Come on.
Well, you should all watch it at some point. But in any case, the movie Hackers is about computer hackers and all that jazz. But they reference in there, and I know this is something Dr. Locklear references as well, that building a library of books, and it becomes a little bit of a weird, quirky thing now because we've kind of moved away from physical books. So most of these you can get as there's a Kindle version of this, as it looks like, and I mean, it's possible for those of you who are unethical that you can find a PDF out there. All right, so in any case, there are some famous books in computer science. There's a red book of cryptography and things like that. Well, the dinosaur book, as it's often referred to, is the de facto operating systems book in computer science. So this guy, Silberschatz and Galvin, they've made a version of this book. It looks like they maybe stopped December 2012 might be the last one. But they have one literally every year for about 15 years before that. They changed 3 words, released it as another $200 book. And yeah, it was a really, really good gig they had going. Maybe one of the guys died, for all I know. That's why they stopped writing it. But in any case, it's called the Dinosaur Book. If you do want a hard copy of it, you can probably go onto eBay or something like that and find an older edition of it. As far as operating systems are concerned, any of them will be fine. Because most of the things that we care about in here are not necessarily related to the latest, greatest, whatever. We're looking at the historical evolution of memory managers. So, for instance, the memory manager that was in Windows 95 is perfectly acceptable to talk about compared to the memory managers that were in DOS prior to that. So, you don't need the Windows 8 or the Windows Vista memory manager. We can talk about what might come next and things like that, but you're not missing out on huge swaths of information. Just like anything else, our software keeps evolving, but from the core concepts that are in there aren't huge changes. They're little changes that add to some performance benefits and that kind of stuff. So if you are interested in getting the a hard copy of the book, which I mean, if you do have a physical library of books, I would recommend it. But get an older edition for $5 off eBay or something like that, and that'll be sufficient. You don't actually need the book for the class. When I give you homework assignments that are like questions and stuff, I'll paste in the questions, and you can use online resources for finding them as well as what we've talked about in class. Okay. Now, to I guess squelch some of your concerns, this class will not be. Let's see, what am I doing here? Oh, I was back here. I would not call this class a programming class. That doesn't mean that there will not be programming in here, but it will not be primarily programming. So your assignments, if half of your assignments are programming, I would be surprised. I think a majority of your assignments will be other things, whether it's doing research and solving kind of a mathy type of equations and stuff like that related to performance and things like that, or writing some papers, although I'm not a huge fan of papers, but sometimes there's benefit to them. But things along those lines. Once we kind of get into some of the deeper things in operating systems, we might start writing some software. We might do some of it in class. I might give you assignments outside of class, but it'll usually be kind of creating, if I just keep using memory managers as an example, how might we implement the memory manager from, DOS 1? We'll talk about how that memory manager worked, and then if you were the programmer back then, how might you implement that? So we almost create kind of a little simulator and things like that, and then I might give you that code as a starting point for you to go and explore, kind of the next step, or make a change to this and tell me what the outcome of this is, something like that. So there won't be tons and tons of programming assignments where you are creating stuff from scratch. I guess I'll say, but don't expect it to be a traditional programming class from me. We're not just going to have programming assignment after programming assignment in here. So I usually keep the papers under 15 pages, and you usually have at least 24 hours to do them. Okay. Questions about the class?
How
Or
quickly do you grade those papers?
I grade papers pretty quick. It actually makes pretty good bathroom reading material. Because in our graduate program,
Bathroom wiping material.
no, I don't use any wiping material.
Haven't you seen
So,
this portable one?
Yeah. So in any case, in our grad program, I teach both programming classes, and every programming assignment that you guys already complained about is coupled by a 3 to 5 page paper. It's part of our accreditation requirement. So imagine that. Imagine you guys think about how much easier you had it by only having one assignment every week. What if you had the programming assignment plus a 3 to 5 page paper?
I would have to.
All of a sudden, that whole thing about bribes might change. I should really consider this.
I'd have to start working on your boat again. That trailer needs some work.
All right. So, any questions about the course in general or anything like that before we just kind of sort of dive in?
Have you decided to paint your boat yet?
Oh, that's going to be a winter project. All right. So I'm actually going to use a starting point slide set from the Soberschatz book, but then I add a bunch of crap to it. So any mistakes that are in here, I didn't write. Anything that's good, I did. So let's find that. And as always, I put the streaming lectures up and stuff like that, and
Will you have the slides up this year too?
well, I'll have the link to iCloud version of it. Is this thing working, or is it zigging when it should have been zagging?
You click down instead of open.
You sure?
I'm like 90% sure. It's not opening, which is making me more sure.
That's true. which is making me more sure. Maybe I hit cancel.
That's possible.
Always double click when in. All right, so let me save this real quick. We're gonna save this here. We're gonna call this CSC350. Fall 2015, Chapter 1. Perfect. And if you do happen to get the book for this, the dinosaur book, this slide set should roughly This looks like it's relative to the 2009 version of the book, but I say some of the stuff is wrong and deviate from it quite a bit. But I like to use this as a starting point so I don't have to recreate a whole bunch of crap. Okay, aren't these slides like shockingly small? Is there a zoom?
That way.
Is there a zoom?
Maybe if you play it.
Yeah.
I don't want to play it.
Go next to the view.
Go down further.
Left,
Zoom.
left, left,
Zoom.
left, left.
Oh, is
Hey.
Oh.
Oh yeah, I even guessed the right one right off the bat.
Perfect, yeah.
I do have a PhD. All right, so some crap we're going to talk about here today. I already mentioned some of this stuff. What do operating systems do? And we're going to talk about that almost immediately here. Computer system organization, architecture, structure operations. We're going to spend a lot of our time this semester talking about process management and memory management. I view these as kind of two very important cores. Something that Dr. Locklear, oh hey doctor, what's kicking? DR. You didn't even know what your name was?
No, like, Dr. Locklear, and I was like,
Oh.
Dr. Locklear must be behind me.
There's the new nickname over there. It's can't talk about that anymore. the doctor. All right. So, in any case, one of the things that Dr. Locklear does talks about is this idea of grand ideas in computer science and how things kind of connect with each other. I really look at process management and memory management and operating systems as being kind of that connection piece to a whole lot of other areas of computer science and how things work. Okay, so we're going to spend quite a bit of time on those. Less so on storage management, but we will talk about file systems some and kind of how those have evolved. And, you know, you've heard of things like journaling file systems and encrypted file systems, things like that. We'll talk about some of those. I won't talk too much about protection and security. Very, very high level. We have a whole security class that it's offered this semester, isn't it? Professor Wall teaches the security class. Good class. He's,
I
huh?
think it's after database.
Who?
I think that class is after database.
This semester.
Database is this semester. Then
Okay,
security
yeah.
class.
But that's a really good class, and he's really competent in it. So I would highly encourage you, if you got room for another class, to jump into that one. Good security class. So we mostly leave security to that. We do spend some time, the last kind of 10% of the course, talking about distributed systems, almost kind of future thinking type stuff. How does the internet, operating systems, desired performance, and bandwidth limitations kind of play into distributed systems either becoming a thing or not becoming a thing? Okay, if you've ever saw the movie Lawnmower Man, kind of that. Nobody saw the Lawnmower Man? Where do you people come from? Didn't see Hackers, didn't see Lawnmower Man. You saw Lawnmower Man, didn't you?
Yeah. I feel kind of old.
I hate all of you. What was I talking about? Oh, special purpose systems. We're not going to, I mean, I probably will mention something stupid, but it's a waste of time. Waste of time, whatever. Okay, so what's an operating system? Why do we need them? What do you think? Isn't it the launch pad for our video games?
I use it to get to Netflix.
That's where the internet lives. So when you think of operating systems, trying to put your computer scientist hat on, what do you think about? What is an operating system? What's its purpose?
Doesn't it like basically convert the machine language to something that we can use, make it more usable for us?
Okay. Yeah, I mean, that's not a horrible answer. I would say that's at least 78%. Okay, so you know, let's translate this into non-Goonies English. You saw Goonies, right? Goonies is like the exact same time frame as Lawnmower Man and Hackers.
Yeah, I'd say Goonies is a little more popular.
I don't know if that's necessarily true.
Oh my
Hackers
God,
was
Goonies is,
big.
like, insanely big. That's like,
All right, so in any case, what was I talking about? Oh, what an operating system does. So we need to think about our computers. So in our programming classes, we talk about programming languages as being this tool that allows us to tell a computer what to do, right? Well, this is for us telling a computer what to do in when there isn't already a piece of software that exists. So how many of you in here are computer science majors, and who's a computer science major? Who's an IT major?
You're all wrong.
Chicago. Oh.
Yeah, I'm actually very impressed that we have a majority of computer science majors, because IT majors, that's the wrong major. Now, here's the reality of that, though. Computer science, IT, different sides of the same coin. I like to look at it as computer science is 75% creation, 25% using what's been created. IT is 25% creation, 75% using what's been created. In both cases, there is creation. That's why we need programming in both sides. Okay, just the types of stuff you're doing, the types of stuff you're creating is different. In fact, in many cases, I would actually argue, for those of you who are debating, who are IT, who are debating whether or not you should take the 300 course and the other programming classes, I might argue that those courses are more appropriate for an IT major than a computer science major, given the types of stuff you'll be programming when you come out of school. Computer science people are going to be writing business applications and things like that, which are going to be much more specialized, using a tool, going into a place. They're going to be training you on their way of doing things with various technologies and stuff like that, where the IT people are going to be much more of like jack of all trades, where you're going to be kind of saying, okay, well, here's the problem I need to have solved. There are some really, really expensive software applications that are out there that I don't have the budget for. So I need to write my own little weird thing that automates some process. Okay, so more often than not, those IT people are going to benefit from the quirky little console-based programming type stuff than the computer science people. Okay, that's my little way of saying it's completely stupid that you don't have to take CSC300. So I would highly encourage those of you who are debating to take that class, because it's more important for I think IT than computer science. It's very important for both, but take that for what it is. You should also all take 470, which is a really cool class, but mark my words. You're going to hear people do nothing but complain about 470 until about 2/3 of the way through the semester. And then all of a sudden they're going to have an aha moment. They're going to say, you know what? All these other things now make sense. Okay, this is after the bleeding of the eyes and stuff like that, which I take great enjoyment from. What was it talking about? Oh, so anyways. Is it? No.
61 million.
Compared.
Hackers, almost 8
Almost 8 people or 8 million?
million. Lawnmower Man, 32 million.
32 million is pretty legit.
Yeah, but like half as much as the Goonies. So.
People watch the Goonies just for the fat kid with a candy bar. And the weird guy with the candy bar. Combination of those two. Chunk. All right, so in any case, we have programming so that we can tell computers unique things to do that aren't already there. Okay? But when we think about using computers, we think about the concept of computing. When you go down to that lab with productivity stuff to do, you expect the software, the operating system, whether you're on the Windows side down there, we run in Windows 7 still. Okay, when you're on the Windows 7 side, you're running, what are we on? Yosemite, okay, or you're on Yosemite. That's a Ryan Guy thing, by the way. Yep. Yeah, Ryan Guy invented Yosemite.
No, I was pretty sure I did.
Out of ignorance or just because?
No. Both. Yep.
You can't complain about Angel eating his homework this year.
It's true. That's true. So, in any case, when you go down there, you have a certain level of expectations about what that software is going to let you do. And our expectations have evolved over the years, right? You know, think back, I mean, many of you in here maybe never used Windows 3.1. How many of you did ever used Windows 3.1? What was the major thing that you could do today that you could not do in Windows 3.1?
What year?
Come on,
timeframe
doctor.
Was 3.1.
Come on, doctor. I don't know, late 90s?
Okay.
Mid 90s? 94, 95?
I was 5 years
Well,
old.
that doesn't mean you didn't, in one of your elementary schools or something like that, you weren't dealing with a low budget situation where they still had old Windows 3.1 machines that they didn't have the money to replace.
So this is pre-Windows 95 then?
Yeah, correct.
Okay. Yeah, Windows 95
So
was.
you said the no internet, right? Okay, well, we'll say that's partially a thing, but that's not an operating system. So this is kind of my point here. We take several things for granted.
Not right.
And as I've done in some of my other classes, is I like to look back so that we can appreciate what we have today, right? We have certain expectations when we go down to that lab in terms of what the machine's going to do for us. What would you do if you could not run more than one application at the same time?
Oh God, no.
I would take the computer up into the mountains.
You can't have your Pandora minimized in the background or iTunes or whatever your
And go into the lab and start using every computer.
second computers. Okay.
Multiple.
Okay. Okay. Windows 3.1 did not support multitasking. Something that we take for granted today. And we're going to talk about how multitasking is actually implemented in here. Why didn't they have it initially and why do they have it today? And how did that transition happen? Okay, but in any case, we have certain expectations of our operating systems, and those expectations have evolved over the years. Okay, now we expect more and more from our operating systems every single year. When Apple announces their new, it was El Capitan this year, which is just stupid. And then Windows 10 just came out. They skipped 9. Anybody running Windows 10? What do you think?
It's alright. Got a few bugs in it.
Well, they all have bugs, Mac and Windows side. I mean, that's
It's way better than 8.
way better than 8. I mean, is it basically Windows 7 interface with Windows 8 stuff?
Yeah.
But in any case, so every single year when they make updates to these operating systems and stuff like that, they're gonna, at least they're not gonna address all of our concerns as consumers, but they're gonna address some of our concerns. Things that the old one didn't do, or the things that we hated. They, like Microsoft's big thing over the last couple of years is what the missing start menu, right? It wasn't that Windows 8 was an inherently crappy operating system. It was a new interface that people were not used to. And because Microsoft Windows is such a large user base, and a large percentage of that user base are not technical people, making that transition was difficult, right? For you technical folks in here, you maybe hated it for the first 5 minutes, but after a day or two, you kind of got used to what's the new way of doing things, and life went on, right? Okay, but Grandpa, where the hell's the start button? Okay. Hey, why do I have to click on 8 things to get to my blue E? Because the blue E is where the internet lives. Okay. Interesting dynamics with that. Like, for instance, just until very recently, which is really interesting, Microsoft has announced that they're discontinuing Internet Explorer, right? Okay.
They just rebranded it.
Just until interesting. We're going to go with that. Just until recently, Internet Explorer was still the most widely used internet browser in the world.
No.
Just until recently. Chrome has taken them over.
W3 schools, they have percentage stats for all that.
Yeah. Internet Explorer, maybe recently is a year.
No.
Yeah.
No.
Yes.
No.
I'm 100% positive on this one. And there's a good reason. If you poll technology folks, Internet Explorer's been in last place for a long time, right? Okay? But our user base in the world is much bigger than technology folks. Okay, when Grandpa goes and buys a computer from Best Buy, the internet lives behind the blue E. It lives behind the blue E. So the largest install base, the largest user base for web browsers was Internet Explorer for a very, very, very long time. And they did not get supplanted until very, very recently. Okay, I don't know if it was a year ago, year and a half ago, something like that, but not a long time ago.
2011.
More recently than that, before they were actually supplanted, I think.
I'd say 2013.
Okay. That might be fair. Yeah. That might be fair. 2013 might be fair. But the point is, it's more recently than you thought. And it's not because the browser was popular. Okay? It's because Grandpa doesn't go out and download Firefox or download Chrome or something like that. So what's the reality today is I think Chrome is the most popular browser kind of across the board, right? Okay. Both Mac and PC users have kind of adopted Chrome as their go-to browser. Fair enough? How many of you are Chrome users in here?
Probably use Chrome for gaming.
Okay. What do you use otherwise?
I don't. Safari.
I don't use a browser. So what you're really saying is your browser is Chrome. Okay. So now outside of that, Mac users, if you have a second place, it's probably Safari, just because that's what came installed in the Mac. Sometimes, I'll use Safari if that's what accidentally opens when I click a link or something like that. Actually, Chrome is based on WebKit, which Apple invented. But what Chrome did is the reason why we all use Chrome is because we like it that it's fast, right? Because they took all the extra bloat out of it and threw it into plugins, modules. So now you can make Chrome slow if you install enough plugins, right? It just didn't come with all that crap that you didn't necessarily want. It's the kind of the punchline. If you have a second place on the Windows side, maybe it's Firefox, let's say. There's another one called Opera that for years has said that they are popular, but nobody uses Opera. Do any of you use Opera? You're lying.
I use it on my iPod.
You go to an Opera.
No,
I've used
Really?
it in the past.
Yeah.
it's not that bad. It's
Well,
just
no, I'm sure it's
simple.
fine. But Opera claims that they're popular. They're not.
No.
they're like, we're the leading browser that nobody uses. Okay. Yeah, the Google Plus of web browsers. I think that's actually reasonable. So, in any case, we have expectations of our operating systems and what they'll do. Okay? So, when we sit down, so this is getting back to answering our question of what's an operating system. Okay, what do we expect from it? What if our machines down there did not have Windows on them or the Mac on them? How would we interact with them? If we didn't have that operating system, we're going to talk about what is and isn't an operating system here in a minute. But if we didn't have that, how would we actually interact with a computer? How did the computing world work before operating systems?
Command prompts?
Well, that's an operating system.
Punch cards.
So you're talking about like DOS,
Yeah, DOS.
Yeah.
disk operating system. That was an operating system.
Punch cards.
So command prompts is what we did before we had the graphical double clicky stuff, right? So that's we're going in the right direction. Okay, we're going back in history. What about before that? The pictures where you see the giant gymnasiums.
Switches.
Okay.
Switches and punch
Okay.
Beat it with a club and carry it to your cave.
Beat it with a club and carry it to your cave. Correct answer. Yeah. We had vacuum tubes. What were you probably talked about these in 150?
Yeah, they
Right.
can go on and on.
Okay, vacuum tubes were basically light bulbs. Lights up, doesn't light up. Lights up, okay. Why do they call them vacuum tubes instead of light bulbs? Probably just made it more expensive, I guess. So, why did vacuum tubes exist?
For ones and zeros to program.
Okay, what did we replace them with?
Transistors.
Transistors. So we used light bulbs to represent zeros and ones before we invented the transistor. Okay, what's a transistor? It's a switch that goes between zeros and ones. Okay, that's what a transistor is. So we used to have these computers that were the size of gymnasiums and could only represent a tiny, tiny, tiny fraction of the amount of data we can represent today, because any number, for example, that you needed to represent had to be represented with light bulbs. Okay, you want a 16-bit number? No problem. We got to find a place to install 16 light bulbs in a row. Okay, and so now we got 5 or 6 numbers. You got a wall of light bulbs. Okay, and you want to do math? Well, we got the math light bulb over here. Okay, you use the 4-bit light bulb array, 4-bit vacuum tube array to determine which of your, I guess it would be a 2-bit vacuum tube array to determine which of your 4 mathematical operations you would do. Operation 00, Operation 01, Operation 10, Operation 11. And each one of those would map to a function, a math function, that would be performed on these 8-bit light bulb arrays that were over here, producing a answer that maybe they gave you 10 bits for the answer or something like that. So you'd just be sitting there staring at light bulbs all day. So to use your computer, you went up and twisted light bulbs. Fun?
So a moth gets in it.
Yeah, I mean, it was a gigantic light breaks.
Did they have to wear sunglasses?
Maybe. Actually, my guess is there was, they don't talk about it very much, but there was probably some substantial radiation dangers. I don't know, they talk too much about the people that, died of cancer from the early UNIVAC or something like that because they were exposed to, atomic bomb level of radiation on a daily basis, just sitting there screwing around with adding 2 numbers together. But, in any case, that's how we used to interact with our computers. Well, we would agree that The machines that used to take up the size of a gymnasium now fit in our pocket. Except what fits in our pocket is thousands and thousands and thousands of times more powerful than what was in that gymnasium. And that's all because of the transistor, right? So when you look at our processors today, before, if we think of a transistor as being a single light bulb, a complex computer in that gymnasium, I'm just going to pull a number out of the sky. Let's say it had 100 light bulbs. Okay? How many transistors fit on a single processor today? Millions. Millions of transistors. And when we look at a processor, most of that is not the processor. Most of that is for heat dissipation. The processor is the actual core. Okay? It's the CPU die. So it's very tiny. So you can really fit millions of processors on like the head of a pencil. Okay? We've downsized a lot. Okay? We have something called VLSI, very large scale integration, where we've squeezed as many things on. And when you see new processors, especially on laptops, they talk about, what are we on now? 0.13 micron? Are we on 0.11 micron? Whatever it is. You know, the idea is that have you seen those numbers related to processors before? You know what they mean? This relates to VLSI, very large scale integration. How close can we print wires on the CPU so that they don't touch each other at the atomic level, so they don't interfere? You know, so it's a measurement of how our technology has improved relative to like doing things on silicon. Did we lose our present? No, we're still kicking. This thing just took it over. You know, we print CPU boards now. You know, we have a machinery that does it for us instead of, back in the Apple IIe days, well, the Apple I days where, they sat there with the soldering iron and, and that kind of stuff. But, now 0.13 microns is how close we can put two highways that move data from one point to another point next to each other without them interfering with each other. Okay? And now we have to deal with heat dissipation, and we don't want them to melt each other either. And we've seen this stuff on a larger scale, those of you who've ever modded a video game system. So for instance, a good example would be if, every new video game system that comes out, their security is usually based on, reading something off the disk or something like that to pass some sort of encryption protocol, right? Yeah. Well, most of the modding systems that are out there are all there to make it as easy as possible so people don't have to take their machines apart, correct? But 100% of them, you could actually bypass the security if you took the machine apart and just made a jumper cable. Before security, after security. We no longer have to go to the gate. Okay, so a lot of places sell kits, like put this little card on here, dump solder here, dump solder here. Thank you for your $50. Right. So in any case, that's how our computers work today. So what if you had to interact with a computer like that today? If you had to interact with those individual millions of transistors, fingers are too big, right? Okay, before we could twist light bulbs on and off, that wasn't the big deal. It sucked, but it was doable. Okay. Now, if we had to go and interact with the millions of transistors, like, whoa, which one was that?
You gotta count.
Huh?
You gotta count.
You gotta count. You gotta shrink yourself down. And you saw the movie. What was it? Yeah, well, that's that. I haven't seen that. Is that any good?
It's pretty good.
I'm thinking about the old.
Honey, I Shrunk the Kids.
I'm going even farther back than that. With the when they shrunk the people down with a syringe and inserted them into the bloodstream, and they had to go and. Okay. But in any case, we would have to shrink ourselves down to go and manipulate them at that. So rather than us having a matter manipulator in the hall, which, I mean, we don't have it here. They have it actually up in Upper Luther. When I first came here, I'm not from Wisconsin. I was from Illinois. And a student was giving me the tour of campus when I was here for my interview and that stuff. And they introduced me to the time machine. How many of you are from Wisconsin that know what I'm talking about? Yeah. That's what they call ATM machines here. Well, so I'm sitting here. I came from a secular school. Yeah, I'm like, okay, time machine. What are these Lutherans up to? So I didn't ask any questions. I just kind of, that was operating in defensive mode at that point. So you got that and the bubbler.
I
That
still
was-
don't get that one either.
Yeah, bubbler was weird. And then soda's not that weird because had already heard of that. Yeah. Oh, big. Yeah. 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 And in Illinois, it's pop. It's water fountain like it should be.
We're drinking fountain.
That's
Drinking
acceptable.
water fountain, yeah.
Water fountain, drinking fountain, acceptable.
No bubbles come out of
Bubbler, it's weird. Time machine.
So why is it called that?
I think the original company that made them here, it's Time, Tyme, take your money anywhere.
Everywhere.
Everywhere, take your money everywhere, rather, yeah. So people just started referring to it as the time machine because of,
Okay.
but, whatever. What does ATM stand for?
Automated teller machine.
Automated teller machine. So really, it's not any better, right? But that's become kind of the normal nomenclature as opposed to time machine that has like where's Doctor Who and stuff like that. All right. So in any case, we have expectations, and we need to have some sort of way of interfacing with those computers, right? Have to have a way of interfacing with those computers. And what we have today is a piece of software that sits between us and that hardware. We don't have the light bulbs. We don't have the shrink ray to go in there and mess with and even if we did have some way of shrinking ourselves down to actually go and manipulate the transistors directly, would that be what we would want to do? We'd like power tools, right? Go back to our description of programming languages, low-level languages versus high-level languages. We don't like programming in low-level languages where we're telling the CPU each individual little magic trick that we want it to do. Why would we want to, forget about programming. Now we're going to go up and actually push the transistor. This magic trick. But no, I'm not done telling you which magic trick yet. That magic trick. Okay, where you're just punching 9 transistors in a row, and that's the magic trick. Magic trick 0011001. Something like that. Okay, so in any case, we have operating systems to sit as a software layer between us, the end user, and the hardware, so that we don't have to deal with that level of tediousness. We can think of operating systems as the high-level programming languages of our modern computer user. Okay? Except the language we're using is the language of double clicks and the keyboard and start menus and stuff like that. Those are the instructions we're giving to the computer as opposed to writing lines of code. So we've all been programmers for a long, long, long time. We solve all of our problems on computers in terms of the tools that the computer gives us, right? Okay? So this kind of comes back full circle to what you learned in 150, that computer science is problem solving. All right? All the time we're solving problems, whether we're computer scientists or just humans. This goes back to when in our first programming class, when I said, how do human beings solve problems? We use our memory, we ask questions, and repetition. Okay? That's how we solve problems in general. An operating system is going to try to put stuff in front of us that lets us act, lets us manipulate computers in a way that's compatible with that, just as programming languages let us do the same thing. Programming languages scare us more because they're a lot more flexibility. They're a lot more flexible. They've done less for us, right? Just like sitting in a car. We sit in a car, we only interface with the public interfaces of it, the steering wheel, the ignition, that kind of stuff. If we sat in a car and all we had was the engine in front of us and we had to kind of reach forward and push on throttle and try not to burn ourselves and stuff like that, all doable things, but not convenient for the average person. Okay, so we've added a layer. So a car is to a computer, a car is to an engine as a operating system is to a computer. Close enough, let's say. All right, so that's what an operating system is. Now, what's your favorite operating system? Is this class 55? We're out? Okay, good. What's your favorite operating system?
Windows 95.
Okay, not an operating system. Keep going. Oh, we got the silence in the crowd. You got a chart of percentages on this one. DOS. closer to an operating system, but not an operating system. Name is misleading. Add my new slide here. Is this a good one? Favorite OSs? Is that right? 4 S's? Yeah. We had Windows 95, non-operating system. We had DOS, non-operating system.
Just Windows.
Just Windows, non-operating. Well, there was no thing just called Windows. We had Windows 1, non-operating system.
Single user.
Just
A single
the
user operating
the
system.
phrase single user.
Single user operating system.
Huh? Yeah, the chart's incorrect. Those are not operating systems. Linux, unless you throw another word on there, that's not an operating system.
Can I say like the PlayStation operating system?
Well, you could if you actually told me what the actual operating system aspect of it was.
Kali Linux?
Who?
Kali Linux.
No, that's not an operating. That's like Windows 95.
iOS.
Nope.
No.
Huh? Nope. None of those are operating systems, fortunately.
Kernel-based operating system.
Everything you guys are describing there are something called distributions. Distributions. The actual operating systems is something called a kernel. All right? So with Linux, the operating system itself is the Linux kernel. With DOS, the operating system is actually DOS. Okay? But there's two sides of it. The distribution is when you install DOS on a computer, it comes with like the edit program and those things. So that's where that one was a little misleading. But Windows 95, the actual operating system was DOS. Windows NT, the actual operating system was the NT kernel. Okay? That's where Microsoft transitioned. So we're going to start off next time talking about history of OSs. Four S's? Yeah. Okay. So we'll start off with DOS, and we're going to put in, we'll say kernel here. Make sense? All right. So all of you have your first assignment. Make sure you get it done on Slack. That one's worth 1,500 points.
When you said so DOS is the operating system that's running on is DOS kernel.
An operating system, the technical name for an operating system is called the kernel. That's the actual piece of software.
So then on Windows it'd be Windows.
No.
So when you insert it, then you go to that.
Well, it depends on the version of Windows. Windows 95, Windows 98, Windows ME, we're all running on DOS.
So then
The other ones were running on, and then they became called the 9X kernel.
so would it be Windows like say Windows 2000 kernel or something?
No, that was the NT kernel. This is what we're going to talk about next time. It's the list of all of them.
For this homework assignment, so the same thing on Blackboard as posting on Slack.
It's not Linux.
What?
This guy can
We have to like submit.
Oh, no, just post on Slack. Yeah, shut up! For the homework assignment, just post on Slack. You don't have to do anything on Blackboard. I'll just use Slack and fill in the grades. All right?